Hello everybody, and good afternoon. So the title of my presentation is Optimum Moisture Content of Substrate Prior to Applying Cementitious-Based Repair Materials. This originally is FAQ, and then currently, the Committee 364 is redeveloping, updating this techno. So it's not there yet. First of all, a few words for Fred, and happy retirement, Fred. And so, Fred to everybody here is, long-term friends, it's, leadership. I've heard a lot of knowledge, but to me, Fred is a great mentor. So I remember in 2010 that when I just joined ACI and ICI, I was very new. I don't know anybody. I work in different committees and try to learn what's going on. And I couldn't remember everyone. The only face I remember is Fred, because he's in every committee that I drop in. So, and then later I realized he's very famous and everybody knows him. So I remember one day at one of the lunchtime at the ACI convention, and I was, this half-hour break there. I tried to grab something, and Fred approached me saying, "Would you like to have lunch together? I remember you reviewed one of my documents." I said, "Sure." I was so flattered. I said, "Great, so it's half-hour quick lunch. We grab something quick." I don't remember every single things that Fred and I discussed, but one thing I do remember is what I put there. Fred told me, "Keep up the good work, and you will learn a lot." So that's I always remember. So 12 years later, with Fred's help, I'm happily involved in ACI and ICI, and I really want to say thank you so much, Fred. I'm here because of you. All right, so back to presentation. The outline, what I want to talk about today is about moisture condition. So why the moisture condition of the substrate is important topic, and how to evaluate the surface moisture condition. What is current industry practice for the moisture condition? And the last is challenging question is what is optimal moisture condition? So starting with why. Now, concrete repairs everywhere. You've seen, contract work on, the parking garage, building facade. And sometimes you find out some, condition like what I've shown here. So repair material has cracked, delaminated, and spot. So, well, and then happens sometime in a couple of months or, within a couple of years. So why concrete, repair does not last long, right? Well, there's three parameters, the big things, right? About, how the longevity of the concrete repair. Start with substrate and the new repair material, and then the bond between the new and existing concrete. Now, the substrate could be you didn't remove enough loose material, or it could have a poor quality. For the new repair material, I think Ben and also Keith have talked about a lot about this not compatible with substrate material, or have high shrinkage, was not very well designed. That could cause a problem for the failure of the repair. There's another thing about the bond. Michael talked about about the bruise condition for the substrate. Well, could cause a problem for the the failure of the bond, failure of the repair. And then there's a condition of potential residual contamination on the surface that will affect the bond and bonding material that we typically use to in the interface. And the two last items that I have here is a concrete substrate posed with water, which is referred to as saturated condition, and all the dry substrate when insufficient moisture is present in repair material. Those two also affect heavily on the bond, and then this is what we want to talk about. So looking at the bonding mechanism in a very simple way. So after chipping the concrete, the substrate near surface or at the surface was left with a lot of open pores. So what's shown on the picture on the the left. So when the repair material was applied, so they absorbed into the substrate by action of capillary suction and the gravity locking around the pore structure, and of course mechanical interlock with the substrate reference. So the condition of those pores is at a bonding surface is most important to because they really direct affect the bond. So to make the life simple, right? What's the moisture condition? We put them in three categories: dry substrate, saturated surface dry, SSC condition, and the wet substrate, So everybody here knows wet substrate will eliminate bond strength. It's not good with the very wet substrate. So we're gonna focus on the first two, conditions. So now we talk about how to evaluate this surface moisture condition. For dry surface, so there's not really different definition of dry surface, but if you think about it, the dry surface is a surface that is allowed to dry, and during the dry time, it has not been subject to hosting down rains or other source of moisture. Drying may take hours or days, depending on environmental condition, also on the property of the material itself. How to evaluate if the surface is dry enough? There's no standard test method available in the STM or other documents. The practical field approach that recommended by the committee members, including for example, place a couple drops of water on the concrete surface. If the water is absorbed immediately, very quickly, disappearing, then the substrate can be considered dry. The other way to look at it qualitatively is observe the concrete color. Typically, commonly, the concrete surface appears to be lighter when it's dry, but darker when it's wet or saturated. Let's look at SD condition. So ACI and ICI have the same terminology for SSD. It is referred to condition of an aggregate particle or other porous source when the permeable voids are filled with water and there's no water on exposed surface. So what does that mean? For aggregates, it means that the particle are fully saturated with no film of water over the surface. For concrete, it means the porosity immediately under the surface is saturated with no film of water at the surface. Looking at a little graphically on this picture, there's two conditions. The top two figure kind of refer to pavement or slab on grade when the bottom slab is against the soil, which is saturated condition. The lower two figure will refer to the bridge deck or elevated slab, and in terms of their moist condition. So look at the right side two figures. So when it's a saturated condition, you can look at how the wiggle line for the moisture condition on the top, where mostly at the very surface, the moisture content is about 90%-ish, and while just below the surface, it has to be 100% saturation. So that's kind of like graphic showing what SSD look like. So how to evaluate SSD condition? There's no guideline available at the current stage. A lot of R&D work, has been performed to investigate device and techniques that to evaluate SSD. Here I list a couple of them that we found in research papers. We all recognize the humidity probes and the moisture meters. Those are usually used at the flooring industry to assess, whether the moisture content of within concrete is ready for receiving the flooring. They're not directly, a method to be used to evaluate SSD condition. There's other few methods that we look at is like they're still kind of in the laboratory stage. Well, you can, use the laboratory method with some, like complex, equipment. That doesn't look like they're ready to be used in the field as an easy, simple way to, look at SSD. So there's field method were from committee members. One is visual inspection, just by looking at the surface. If there's water glassing, at the surface, then the surface is saturated, not SSD condition. The other way is try to jetting a stream of compressed air on a concrete surface and with a cardboard on the back. Then when you have a flow of high velocity air with deflecting air with visible moisture come to the cardboard, and that means the surface is still saturated, not SSD condition. So this is what we know for now, what we can definition and evaluate both dry and then the SSD condition. So what is current industrial practice for moisture condition? We've looked at ACI and ICI, guideline documents. The only one particular talk about the specific about the surface preparation regarding the moisture condition is ICI guided specification for structural concrete repair. The paragraph 3.4H bounding and refers specifically on saturated surface dry substrate and talk about pre-damping concrete surface, substrate surface to SSD immediate prior to placement. There's also more commentary on this particular, like clause about the area must be properly damped with water prior to the application of bonding crowd bonding agent, except in case when the proprietary bonding agent can cause for a dry surface. Additional commentary will including, the wet repair substrate more than once or for a period of 2 hours or longer in order to achieve proper damping. And then they also mentioned professional, design professional should work with the contract to determine the procedure based on confirmation through testing that a specific bond strength is need to be achieved. So there's a lot longer than that, but this is what I'm going to cover here. Well, we know we use a lot of proprietary repair material, right? We're using, from the manufacturer. So looking at their data sheet or guided, general instruction from their, product, it looks like every product referred to SSD. So here I screenshot 3, products repair mortar or repair microconcrete from 3 major repair material manufacturer, and then highlight the language about the moist condition. As you can see, all of them refer to SSD condition. So that's what we, see in general case. So the question is, what is optimal moisture content? Is it SSD? There's limited research that we can find at this moment, and the primary documents that I will talk about in this presentation is the 3 I list here. But the overall big picture, just before getting into detail, is all of this research refer to a drier substrate to be a better or optimal bond that's actually works. So let's look into that. Saucier and the Pigeon and publish an article, I think title of Durability of New to Old Concrete Bonding, and then they were published in the ACI special publication back in 1992. Here shows a figure of, a bond strength test over 87 pair of testing, really tested, so with repair material on the dry surface and also on the wet surface that was wet for an hour. They will also, have several conditions of no bonding agent was used, and then with a cement slurry bonding agent with high or low water cement ratio, and also latex-based commercial bonding agent. The bonding strength, either in shear or either in tension, kind of present here based on those 2 conditions, and then you can see that, in a big picture, there's no significant difference, observed. They didn't mention, based on a close review on the statistical analysis, there is difference about using different bonding agent will have some results. Some of them refer to higher bond strength with, with the dry surface, which is mostly applicable. Only in one case, they found out, when they use a cement slurry with a high water cement ratio, they said the bonding strength actually is slightly higher when the substrate is wet. So that was only in case that they mentioned. The second publication I'll talk about here is the Schrader, published an article in Concrete International in 1992, where he talks about controversial items on the concrete and concrete repair. He talked about specific on effect of pre-wetting on bond, where he reviewed and collected some data and presenting table that I'm showing here. And it's pretty apparent, they talk about all the concrete, dry mixed shotcrete, and latex modified shotcrete with in the dry condition and the wet condition and wet SSD condition. And the test results showing shear or or tension kind of apparent showing that the drier surface actually promotes higher bond strength. So he concluded that wetting a surface prior to placing an overlay or patch is not always the ideal case. So last article I mentioned here is Weisberg and also Benoit work on that for the U.S. Bureau of Reclamation, where they did a lot of research work. Here I just grabbed 3 figures about the bond strength of 3 different repair material, 5,000, 7,000, and then 3,000 psi repair material. Well, under 3 condition, if you see the bottom horizontal scale is very dry surface, or with 1 hour wetting, then air dry to SSD, and with 6 hour pre-wetting, and then air dry to SSD. And you can pretty much see from these figures that there's pretty much showing that the bond strength is very similar between all 3 conditions, and it's actually better with a dry surface, in this case, especially with 5,000 and 7,000 repair material, which is commonly used for our repair work. So summarize what I just talked about in the last 15 minutes is the moisture condition has a direct effect on the bond strength as durability of repair. Evaluation of moisture condition, especially SSD condition, does not have a clear guideline. The current industrial practice recommends SSD as preferred moisture condition to receive new repair material, and the limited research suggests, actually a drier surface may achieve an improved bond. So with that being said, there is a need in industry to improve the guideline regarding moisture condition of the substrate prior to repair. So what we need to achieve and how to evaluate that condition. SSD as a rule to be considered in view of report data and additional literature review that we may need to do. So as I mentioned in the beginning of this presentation, we're currently developing a tech note to address this gap, in the repair world. And then if you're interested in this topic, have some knowledge or insight, we're welcome to join our committee and then participate, and then hopefully we can help repair the industry to address this gap. Thank you so much.